106 to 1. That is the ratio between the cost of the weapon used by Iran and the weapon used by the United States to stop it. The cost of building a Shahed 136 drone is about $35,000, while the THAAD interceptor used to destroy it costs roughly $12.7 million in simple terms. For every $1 spent on offense, the defender must spend about $160, and the attacker can produce these weapons in the thousands. Meanwhile, the defender is running out of time. In many ways, this single number reveals more about the current conflict than any headline, casualty count, or satellite image ever could. This conflict is not just about military capability, it is about the economics of warfare in the 21st century. The entire American military-industrial complex, the Pentagon's acquisition system, and the strategic doctrine developed after the Cold War were never designed to deal with this kind of cost imbalance. Today, I want to give a clear technical explanation, supported by real data, of why the most powerful military in human history is struggling against an opponent with only a fraction of its industrial capacity, budget, and technology. Why are the same weapons that defeated Saddam Hussein in 3 weeks and forced Yugoslavia into submission not producing the same decisive results against Iran? Why is Iran still firing after nearly 2 weeks of one of the most advanced and expensive air campaigns in modern history? And what does this mean for the future of warfare around the world, not just in the Middle East? Because the story is not only about Iran, it is about a real-time collision between two completely different philosophies of warfare. And even if one side may be losing the physical battle, it may still be winning the financial one. In long wars, the financial struggle often determines the final outcome. To understand why this is happening, we must first examine the American model of warfare, because it dominated global conflict for decades. Between 1991 and 2003, the American strategy of war was built on 3 interconnected pillars. The first pillar was information dominance. This included satellites, surveillance aircraft, advanced communications, intelligence networks, and electronic warfare. The goal was simple: see everything, track everything, and understand the battlefield in real time. If you can see a target, you can track it. If you can track it, you can destroy it. During the 1991 Gulf War, coalition forces could observe the entire Iraqi battlefield from orbit. Iraqi commanders, by contrast, were essentially blind. They could not communicate safely and often had no idea where their own units were relative to the advancing American forces. The Americans were fighting with complete visibility while the Iraqis were fighting in confusion. The second pillar was precision. This meant using highly accurate weapons such as laser-guided bombs, GPS-guided missiles, and precision-guided cruise missiles. These weapons could destroy a specific target inside a building without destroying the entire neighborhood. This was not only a humanitarian improvement compared to carpet bombing, it was also a powerful tactical advantage. Precision meant fewer weapons were required for each target. Fewer weapons meant fewer sorties. Fewer sorties meant faster campaigns. Precision also allowed the United States to strike the enemy's critical nerve centers, command posts, communication hubs, and leadership targets without destroying the entire country. The third pillar was logistics. This refers to the ability to move fuel, ammunition, spare parts, aircraft, ships, and personnel across the globe and sustain military operations for long periods of time. When the United States decides to fight a war, it can quickly transport everything it needs to the battlefield and maintain operations almost indefinitely. No other country on Earth possesses a logistical network like the United States. Its global bases, aerial refueling tankers, prepositioned supplies, and naval power function as strategic weapons themselves. Without this logistical infrastructure, strike aircraft cannot reach the battlefield, remain operational, or be replaced. Against the kinds of enemies this model was designed to defeat, it was almost unstoppable. Traditional armies rely on permanent infrastructure, large bases, and organized formations occupying identifiable territory. These fixed targets could be located and destroyed. The American model was so powerful against these opponents that the wars often appeared almost unfair. During Desert Storm, after 38 days of one of the most intense air campaigns since World War II, Saddam Hussein's army collapsed in just 100 hours of ground combat. But over time, something changed. For more than 25 years, many countries carefully studied American warfare. They analyzed every U.S. military operation, every strength, every weakness, and every assumption behind the American system. Eventually, a critical strategic conclusion emerged. The best way to defeat the American model is to avoid fighting like a conventional army. Among America's adversaries, Iran reached this conclusion earlier, more consistently, and more effectively than most. The current conflict is essentially a real-time demonstration of what 4 decades of studying American warfare looks like when it is fully implemented. Iran's approach is surprisingly simple, yet highly effective. It is built on 4 core principles. The first principle is mass over precision. Instead of investing huge resources in a small number of extremely advanced weapons, Iran focuses on producing large numbers of inexpensive but good enough weapons. The Shahed 136 drone is a perfect example. It is not maneuverable. It flies slowly at about 120 km/h and follows a GPS-guided path. Its warhead is relatively small compared to a ballistic missile. By every standard of individual performance, it is a relatively weak weapon, but that is not the point. The real idea is that hundreds can be launched at once. For the cost of a single THAAD interceptor system, thousands of drones can be produced. When a defender must spend $12.7 million to shoot down a $35,000 drone, the mathematics quickly becomes catastrophic for the defender. The second principle is distribution instead of concentration. The American model concentrates power: large aircraft carriers, massive bases, and dense military formations. Concentration increases efficiency, and it allows huge amounts of power to be projected from one location. However, concentration also creates large, visible targets. Iran does the opposite. Its missile launchers, storage sites, and command systems are distributed across the entire country. Mobile launch vehicles can relocate frequently. Launchers are hidden in forests, industrial zones, valleys, and rural areas, places that are often absent from traditional targeting databases. This distribution reduces efficiency, but dramatically increases survivability. The third principle is resilience over sophistication. Iran's underground missile infrastructure was developed over 4 decades specifically to survive the most powerful bombing campaigns imaginable. These facilities are not technologically complex. Most of them are simply reinforced tunnels carved into rock and concrete. But their simplicity is precisely what makes them effective. Advanced bombs may destroy sophisticated systems, but they struggle against deep, hardened underground structures. In long wars, survival often matters more than technological sophistication. The fourth principle is financial attrition over military devastation. This is the aspect that the news almost completely ignores, even though it may be the most strategically significant. Iran does not need to destroy the US military in order to win the financial war. It simply needs to force the United States to spend money faster than it can replenish its weapons. A THAAD interceptor costs about $12.7 million to produce and requires a complex industrial process. Last year, the United States produced only 96 of them, though production is expected to increase to about 400 per year. At the same time, Russia's Alabuga plant is reportedly producing roughly 5,500 Shahed drones each month, with each drone costing around $35,000. If Iran launches 100 Shahed drones, the total cost to Iran would be about $3.5 million. If the United States fires 100 THAAD interceptors to stop them, the cost rises to about $1.27 billion. This kind of exchange does not need to happen very often before the math becomes tactically and financially unsustainable. One of the most important documents for understanding the financial side of this conflict is the CSIS analysis of the first 100 hours of fighting. According to that report, the United States spent an estimated $3.7 billion just to replenish the munitions fired during the first 100 hours. Operational costs were estimated at roughly $891 million per day. According to Jennifer Kavanaugh of Defense Priorities, the United States may have spent more than $10 billion on air defense systems in the first 48 hours alone. Using Department of Defense budget data, the New York Times calculated that the interceptor-to-drone cost ratio is approximately 106 to 1, meaning it costs about $16 to defend against every $1 of attack. CSIS further estimated that if Iran continued attacks at this scale across 10 separate engagements over the course of a year, interceptor expenditures alone could total between $50 billion and $100 billion. For fiscal year 2026, the United States plans to spend between $15 billion and $20 billion on missile defense. The interceptor costs alone in this scenario would require 5 to 6 times the entire missile defense budget. And this calculation does not include aircraft sorties, ship operating expenses, manpower, logistics, intelligence gathering, or command and control infrastructure. This is where the financial argument becomes physically serious because it leads directly to the stockpile problem. As of December 2025, the United States had about 534 THAAD interceptors in its global inventory. During a 12-day conflict in June of the previous year, between 100 and 150 of them were used. That means the United States may have had as few as 384 THAAD interceptors remaining worldwide before February 28th, covering not only the Middle East, but also the continental United States, Korea, Guam, and Europe. During the early stages of the current conflict, the rate of THAAD usage against Iranian ballistic missiles was reportedly even higher than during the June conflict. According to CSIS estimates, at current usage rates, the entire THAAD inventory could potentially be depleted within 4 to 5 weeks of sustained fighting. Even with production rising to 400 interceptors per year, the United States would essentially spend an entire year of manufacturing capacity replacing what could be used in a single week of intense conflict. And THAAD is not the only system under pressure. The U.S. Navy's SM-3 interceptors used on Aegis missile defense ships numbered about 414 in stock as of December 2025, with 80 already used by mid-2025. Patriot PAC-3 interceptors, produced by Lockheed Martin, reached around 600 units in 2025, with plans to increase production to 2,000 by 2027. The rate of consumption in modern missile warfare is staggering. In just the first 4 days of this conflict, the United Arab Emirates alone reported intercepting 174 ballistic missiles, 8 cruise missiles, and 689 drones. And that represents the air defense effort of only one country. On March 5th, Ukrainian President Volodymyr Zelensky made a striking observation. He stated that in just 3 days, more Patriot missiles were fired in the Middle East than Ukraine has received since Russia's invasion began in 2022. In other words, 3 days of air defense operations in the Gulf consume more interceptors than 4 years of Ukrainian defensive spending against continuous Russian missile attacks. This situation is difficult to sustain. At present, there is no production rate in the global defense industry where the math works, and these calculations are not limited to academic analysts. They are being examined inside the Pentagon and in the defense ministries of allied governments across the Gulf. Those officials know exactly what the stockpile numbers look like. They also know that the adversary draining those stockpiles is producing its main weapon in a factory capable of manufacturing 5,100 drones every month. However, it is important to be fair and acknowledge the technological response. The United States has adapted, and in some areas, it has done so with impressive institutional speed. One of the clearest examples is the Lucas system, a low-cost unmanned combat attack drone developed by reverse engineering the Shahed 136 design. In fact, Iranian-style drones had already been used to attack American bases. Within about 18 months, American engineers studied the design, improved it, and created an American equivalent. Each Lucas drone costs around $35,000, replacing missions that previously required $2.5 million Tomahawk cruise missiles. Lucas drones reportedly made their combat debut during the opening strikes of Operation Epic Fury, launched from U.S. naval vessels. In this case, the United States effectively turned the cost imbalance of cheap drones versus expensive missiles against Iran's own air defenses. This represents the U.S. military at its most adaptive. Instead of relying on the traditional acquisition system, where developing a new fighter aircraft can take 15 years, units such as Task Force 59 used rapid prototyping authorities to transform a foreign design into an operational American system in less than 2 years. This is the same innovative military institution that produced GPS, the internet, and stealth technology in earlier decades. When it moves quickly, it can adapt remarkably fast. The development of Lucas shows that many Pentagon officials understood the lesson emerging from the war in Ukraine. Cheap mass can force disproportionate spending by technologically advanced opponents. However, Lucas solves only part of the problem. It is primarily an offensive weapon. Using a $35,000 drone to strike Iranian air defenses is a major improvement in cost efficiency. But on the defensive side, the United States still relies heavily on $12.7 million THAAD interceptors to destroy $35,000 drones. In other words, the economics of offense have improved, but the economics of defense remain fundamentally broken. Another adaptation being explored by the United States and its allies is the use of directed energy weapons, particularly laser systems. The U.S. Navy has already deployed shipboard systems such as Helios, the high-energy laser with integrated optical dazzler and surveillance. The advantage of laser weapons is simple. Once the system is installed, each shot costs almost nothing. Instead of firing a missile costing millions of dollars, the defender is essentially paying only for electricity. A similar concept exists in Israel's iron beam laser system, which has reportedly been used in limited operational scenarios. The idea is appealing. Build the system once, and then fire thousands of times at almost zero marginal cost. However, directed energy weapons are still in the early stages of operational deployment. Current laser systems are effective only at relatively short ranges of a few kilometers, primarily against small drones. Their performance can also degrade in rain, dust, or sandstorms, conditions that are common in the Gulf region. Most analysts believe directed energy systems could significantly change the cost equation of air defense between 2028 and 2030. But the current conflict is happening right now. So the reality today is this. The United States possesses unmatched strike capabilities. Its B-2 bombers, F-35 fighters, carrier strike groups, precision weapons, satellites, and command systems allow it to strike targets across Iran with extraordinary accuracy. Iran cannot replicate that level of military power projection. Iran's air force is largely obsolete. It has no aircraft carriers and very limited ability to project conventional power beyond the Gulf. But Iran has built a different kind of military strategy, one designed not to project power globally, but to impose costs on anyone who attacks it. This strategy deliberately targets the greatest strengths of the American model: its reliance on precision, advanced technology, and expensive weapons. Iran recognized long before this conflict that the most important battlefield in a confrontation with the United States would not be the skies over Iran. It would be the budget line, the defense industrial base, the stockpiles, and the political sustainability of spending billions of dollars per day in a prolonged conflict. A recent analysis from the Council on Foreign Relations described the problem clearly. It concluded that, when it comes to precision mass offensive weapons, the United States is currently on the wrong side of the cost curve. In many engagements, defenders spend 5 to 100 times more than attackers. This is not simply a temporary imbalance. It reflects a structural shift in the technology of warfare. A study by the European Policy Center, published before this conflict but strongly validated by it, described the broader trend. Cheap drones, commercial electronics, artificial intelligence, and satellite navigation have flattened the technological pyramid of warfare. Precision is no longer rare or expensive. It can now be delivered cheaply and at scale. Iran refined a strategy that had already been visible during Russia's drone campaign against Ukraine. Military analysts watching that conflict quickly realized that the Shahed drone was not just a weapon. It was a financial strategy. Each attack forced Ukraine and its NATO partners to fire extremely expensive interceptors at extremely cheap drones, slowly draining missile stockpiles. Iran observed those dynamics closely. After all, it was Iranian drones that enabled much of that campaign. It then applied the same strategic logic on a much larger scale. Since Desert Storm, the American model of warfare has relied on precision, technological superiority, and high-cost weapons to win battles quickly. Iran's model, by contrast, focuses on cheap, scalable, and resilient systems designed to survive long conflicts. Early data from organizations such as CSIS, the Council on Foreign Relations, the Congressional Budget Office, and defense industry production schedules suggests that this strategy is working, not by outperforming American technology, but by draining American capacity. The question facing military planners is not whether Iran is winning the battlefield. It is not. The real question is whether the United States and other wealthy nations with similarly expensive military systems can afford to defend that model indefinitely against an opponent exploiting its economic weakness. As the old saying goes, amateurs talk strategy, professionals talk logistics. At its core, this conflict is a battle of industrial economics and logistics. And right now, the side with the most expensive weapons is losing the economic argument. If this framework helped you better understand what the headlines are describing, share it and continue the discussion. These numbers matter for every nation that must consider how wars will be fought and financed in the 21st century. Leave a comment with your ideas. I'll see you at the next one.